Hello, good day everyone. Welcome back once again. Today we'll be solving for the value of x in the following nice looking equation. We have here root x raised to the power of root x. This is equal to 2. Here we'll be solving for x. But before we proceed, let us make the following substitution. For my substitution, I'm going to let square root of x equals y. Obviously, if we square both sides of this equation, we have x is equal to y squared. So my target is to solve for y squared because that will give me exactly the value for x, right? Now for the equation, we transform that equation from root x raised to the power of root x to y raised to the power of y, and this is equal to 2. Now, let us think about what to do. We all know this type of equation, we can solve it in different ways. But in this video, I'm going to make use of the Lambert W function, right? Our target is to obtain something like this. The w of x times a raised to the power of x, this evaluates to x, right? So from the left hand side, our target is to obtain something like this. But let's see how we're going to do that, because the argument of this Lambert W function is very interesting. We can see that exactly the power of e is exactly what the coefficient is. So if the power of e and the coefficients are equal, then the Lambert W function operating on this will give us x, right? So let us ln both sides of this equation. So here we have the natural log of y raised to the power of y. This is equal to the natural log of 2. Now with the property of the natural logarithm, that the ln of let's say we have x raised to the power of t, this is equal to the power crossing over, we have t times the ln of x, right? So here we're going to have y multiplied by the ln of y, and here this is equal to the natural log of 2. Now let us recall another nice property of the natural logarithm. We know that t can be rewritten as e raised to the power of natural log of t, right? Now we are going to write this y in exponential form. So here we're going to have e to the power of the natural log of y multiplied by the natural log of y. This is equal to the natural log of 2. So we can see what is going on. Our target is to obtain something that will look similar to this argument of this Lambert W function here, e to the power of x times x. And here we have e to the power of natural logarithm of y times exactly the power natural logarithm of y. So from here we can take the Lambert W function of both sides. So here we have the w of what we have from here. This is equal to the w of the natural log of 2. And with the property of this Lambert W function, we all know this simplifies to the natural log of y, and this is equal to the w of natural logarithm of 2. Now, we are going to solve for y squared, but from here we can actually manipulate this equation to obtain y squared, which is exactly equal to x. So what do we do? For the fact we know that a times the natural log of b is the same as the natural log of b to the power of a. What if I multiply both sides of this equation by 2? And here I multiply here by 2. We can see from the left we have 2 times the natural log of y. This is equal to 2 times the w of the natural logarithm of 2. And with this property here, this becomes the natural log of y squared. This is equal to 2 times the w of the natural logarithm of 2. And from here, we know this property. When we have the natural log of x to be equal to t, here x is the same as e to the power of t, right? So for here, y squared is equal to e to the power of 2 times the w of the natural log of 2, right? And we can see what has happened. Y squared is exactly x, and from here we can replace y squared with x, and here we obtain the value for x. X is equal to e to the power of 2 times the Lambert W function of the natural logarithm of 2, and with the help of my calculator, this is approximately equal to 2.43238481646, and this is the solution. Thank you for watching. Please kindly subscribe to my channel. Also like, comment and share. Bye bye.